When you think about heavy industry, your mind probably jumps to massive explosions or really complex machinery, right? But a lot of the time, the biggest, most constant threat comes from something we all deal with every single day: gravity. So we're going to dive into the surprisingly deep science of just preventing things from falling and see how a really systematic approach can tame this powerful, fundamental force.
I mean, just look at the scale of this thing. A modern drilling rig isn't just a tall building. It's practically a vertical city made of steel, soaring hundreds of feet into the air. You've got tons of equipment and crews working at every single level. Up there, gravity isn't just some force you learned about in school. It's a constant, silent predator, just waiting for one tiny mistake.
So the official term for this kind of hazard is a dropped object. And the definition? Well, it sounds almost laughably simple. Any object that falls from its previous static position. It could be a wrench, a bolt, even a water bottle. Simple, yeah? But when that simple object falls from 100 feet up, it becomes a deadly weapon.
So the challenge is pretty clear. How do you manage this constant danger from above? And the answer isn't just putting up a sign that says, "Be careful." No way. It requires a super comprehensive top-to-bottom strategy.
Okay, now this is the part I find absolutely fascinating. The goal here isn't just to reduce the risk. The goal is total prevention. I mean, look at that. Eliminate injury, eliminate damage to the object, eliminate damage to other equipment. It's an absolute. The target is zero. That's a pretty bold mission.
So how on earth do you even get to a goal that ambitious? Well, definitely not with wishful thinking. You use a detailed 5-step plan. And as you're about to see, this is not some simple checklist. It's a complete blueprint for building a safety culture right from the ground up. And here they are, the 5 steps. It's this continuous loop, see? It kicks off with an awareness campaign, which makes sense. Then it moves into an action plan to actually find the hazards. After that, you've got remedial action to fix what you found. Then you review how everything's working, and finally, the most important part, continuous improvement. It never stops. So let's dig into what that action plan really looks like. How do you inspect something this huge?
So how do you inspect a structure that's basically the size of a skyscraper? Well, you don't. You can't. You inspect it one manageable piece at a time, starting at the very top, what they call the crown, and working your way all the way down to the rig floor.
This right here is the strategy, and it's brilliant. The whole derrick gets broken down into these smaller, manageable zones. This is how you make sure that no bolt, no bracket, no single piece of equipment gets overlooked. Inspectors can get super focused on one small area before they even think about moving on to the next one. All right, so with the zones all mapped out, the inspectors start the really painstaking work of combing through every square inch, and they're trained to look past the obvious stuff and spot the potential hazards, the things that could become a problem later. So let's kind of follow along with them and see what they find.
Here is a perfect example. This piece of equipment, it's called a monkey finger, and you can see right there, it's missing its securing tin. Now, it might just sit there for days, maybe even weeks, no problem, but all it takes is a little vibration at the wrong moment, and this solid chunk of steel is coming down.
And hey, it's not just about heavy gear. Check this out. A forgotten water bottle and some loose wires. It seems like nothing, right? Totally trivial. But from 100 feet up, that water bottle can hit with the force of a sledgehammer. And that's the key takeaway here. In this environment, there's literally no such thing as a harmless dropped object.
And here's another one, a bundle of rope, just sitting there, totally unsecured. It is a classic example of just poor housekeeping that could have absolutely catastrophic results. It's these small, seemingly tiny details that this whole inspection process is designed to catch.
So, once a hazard is found, the very first step to fix it is incredibly simple, but really powerful. The inspector asks one question: is this thing essential for the job right now? And if the answer is no, it's gone, removed immediately. That alone declutters the entire work site and just eliminates that risk completely.
Okay, but finding and removing stuff is only one part of the solution. You can have the best system in the world, but it's not going to work unless the people running it are trained properly and they know exactly what their responsibilities are. So let's see how this whole thing builds into a culture of safety. A system like this only works if there's clear accountability. And as you can see, the responsibility is defined all the way from the top down. The project manager has that big picture view, sure, but it's the rig manager who's on the ground every day making sure these rules are more than just words in a manual, that they're actually being followed.
This slide just lays it out perfectly.
It shows you the problem versus the solution. On the left, there's that hazard we saw, the unsecured rope. And on the right, you've got the standard procedure. Every single tool used at height has to be tethered with a lanyard. It's such a simple control, but it makes a world of difference.
And this is where that cultural shift really starts to happen. The training empowers every single person on the crew to basically become an inspector. They're not just there to do a task. They are actively looking for risks, from spotting worn-out rigging to just practicing good housekeeping. In a system like this, safety becomes everybody's job.
All right, so now we get to the final and maybe the most important piece of this whole puzzle. This is not a one-and-done inspection. It's a process of continuous improvement where the system itself is actually designed to learn from mistakes and get stronger over time.
So how does a system learn? Well, the key is its attitude toward failure. Even a near miss, an object that falls but luckily doesn't hit anyone or anything, is treated like a serious incident. It's not a moment of relief, it's a warning bell. It has to be reported, it has to be analyzed, and it has to be used as a free lesson to prevent a real tragedy down the road.
This commitment is literally baked into the process, as this quote from the manual shows. The idea is to share everything you learn, the good and the bad, across the entire organization. A lesson learned on one rig in the middle of the ocean can prevent an accident on a totally different rig, maybe thousands of miles away.
So this systematic approach, zoning, inspecting, learning, and always improving, protects workers from one of nature's most basic and relentless forces. It really makes you wonder, doesn't it? In our own everyday lives, from the office buildings we walk into to the airplanes we fly on, what other hidden risks are being managed all around us by complex systems we never even see?